This meeting is being recorded.
In the first section of Chapter 9, we're going to review and introduce these structures, alkynes, and how they react. So last chapter, in Chapter 8, we looked at a lot of different addition reactions for alkenes, which we know have double bonds involved. So here's our simplest alkene. Here we have ethene. So we're going to expand on the reactivity of alkenes and see if we can look at alkynes and see how they're similar or different. So this first image here gives us the orbitals of the CC triple bond. So if you recall, a triple bond has one sigma bond, and that's shown right here with this head-to-head overlap of these two hybridized orbitals in our carbon. And then we have two unhybridized p orbitals. So I'll try to outline one over here, and then we have one over here. These two p orbitals will be involved in one pi bond, and then we have, again, a second pi bond here. So two pi bonds give us our triple bond collectively. So we have one sigma, two pi bonds, and then the pi bonds result from the side-to-side overlap of these p orbitals, the unhybridized p orbitals. So let's look at this next image here, and we can see that there's a high electron density in the central region here of our alkyne, and due to this, the presence of all these pi bonds, we'll see that we have similar in the ability to act as a nucleophile to alkenes. So alkynes and alkenes are similar in this aspect. So many of those addition reactions that you just learned about for alkenes will also work with alkynes. So the textbook presents some industrial products such as acetylene that is a gas, and it has generally this structure. It's the simplest, right? So we'll draw hydrogens on the end here of these two carbon atoms that are triply bonded to one another. So it's the simplest alkyne, and it's used in blowtorches in industry, and it gets up to about 2,800 degrees Celsius. If you need a very hot flame to do welding and things of that nature, you can use acetylene gas. Another aspect, right, it's also a precursor for synthesis, so for making new molecules and more complex alkynes specifically. So there have been many alkenes isolated from natural products, so many double bonds in compounds that are from natural sources. Even though there are less alkynes from natural products, we've seen more than 1,000 different alkynes that have been isolated from these natural sources. One product listed down here, right? We see this molecule name down here. We can see two triple bonds highlighted in green here. So we had mentioned acetylene or smaller alkynes can be used to synthesize larger molecules. One of these is this ethynyl estradiol, and it's a diol, right? We can sometimes pick out where the names come from because it has two hydroxide groups. But other than that, we really won't have to, worry about the nomenclature of molecules quite this size. But this is an example of an alkyne that's used as an active ingredient in many birth control pills. And it's actually more effective than a natural analog. Your textbook explains this very well because of this triple bond here. So that's everything from section 9.1. We'll take a look at 9.2 and how to name alkynes in the next video.